Hello, everyone. Welcome to this red hot session on lifecycle management through ORDS. In the next hour, we want to show you how Oracle REST Data Service, also known as ORDS, can help you with your DevOps process on Oracle databases. My name is Rana, and with me today is Piotr. We're both part of the domain specialist team from the database development. So for this session, I will focus with you on ORDS. Piotr will take you through the DevOps journey in the next part. In this session, we want to give you a helpful overview on the different ways that you can leverage ORDS and specifically focus on the ongoing need, of course, that we have for lifecycle management and give you a new way of looking at it. So our aim today is not to do a deep technical dive, but more to highlight the bigger picture, give you a brief of the steps that you need to achieve this, and then how we can help you further. So let's jump right in and start with today's agenda. Firstly, we'll talk about what exactly is ORDS, when should ORDS come up, and how we can use it. Then specifically using ORDS for continuous integration and continuous development, we'll talk about the benefits, how we can set it up, and then show a quick demo of us testing it. And then we'll talk about the DevOps for Oracle databases. And finally, we'll have some time for Q&A. In the meantime, of course, feel free to drop in your questions in the Q&A section. We will try to answer as much as we can through the Q&A and at the end as well. So starting off with, what is ORDS to begin with? From our architecture perspective, ORDS is a Java application that can be deployed whether in standalone architecture, and it contains, in this case, an embedded Jetty web server, or it can be rolled into an existing Tomcat or WebLogic server. So putting this in more simple words, ORDS is basically a Java application that enables your users and developers to develop REST APIs for Oracle databases. In terms of connections, a connection pool will be serving a database. So you could have ORDS supporting multiple databases, and that would mean that there would be multiple JDBC connections in this case. Each database, of course, will get its own mapping pattern. So for example, like ORDS/database1, for example, and that would be the URI that we would use in order to access the requests. So this is one option of using it, but you can also have ORDS for each of the databases that you have. This is completely up to the developer and the specific use case that they're using it for. So now, when should we use ORDS? When should ORDS come up as a service when we need it? The most fundamental application for this, and the one that you may be already familiar with, is the fact that ORDS acts as a web gateway for the database and for any programs that we plan on running on it. This is by taking the PL/SQL procedures or functions that we have and sending them as HTML for the client screens, whether you're running it on web or mobile, for example. But this is not all. ORDS also allows you to execute RESTful calls on your database so that you can easily manage the data that you have. And with ORDS, you can also manage the database itself. This means performing some of the DBA tasks with the web client like SQL developer. So possibly you could be able to query the data, tune the database, and manage it from the REST APIs. You could also be able to publish these as REST APIs themselves, so you can take care of all of the database management actions. And then it's important to note that ORDS is not just limited to relational forms of data. You can also use it in order to manage document style and non-relational formats of data by using REST for SODA. This is very useful specifically if you're more accustomed to the Mongo style for databases. So let's explore this further. ORDS as a web listener is mainly relevant when talking about database application development, specifically when using Apex, our low-code application development platform. So in order for you to have proper infrastructure so that you can run all of your database apps directly on top of your database, you need ORDS as your main gateway. Then when we talk about how we can access these database objects, so we want to access tables, views, procedures, anything that we have in our database through REST, ORDS can really help us specifically with the auto-REST feature. This allows us to automatically create the REST APIs for the database objects that we have. This feature, again, extends the concept of low-code, where with just one simple PL/SQL statement, we can actually REST enable our database objects. However, if you prefer to have more control, more customization over the APIs that you publish, you can still build your own requests in ORDS without using the auto-REST feature. And by default, ORDS will help us abstract a lot of the tasks by taking care of the pagination by default, taking care of the HTTP responses. So this way, we're not overwhelming the client with this. Then with respect to security, the REST APIs will only have as much control as we have defined in the schemas. So for example, if an unauthorized user will attempt to make a request to drop a table, for example, delete some records, this will not be allowed as per the security schema definitions that we have defined themselves. And then in addition to all of that, we can do all of this through the interface of our choice. So we can do this through using SQL Developer. We can also use Bash. We can use the PL SQL API. And one of the easiest options also to use is using the REST GUI. This is very intuitive. It's provided both in Apex as well as SQL Developer Web. Then we need to note here also that one of the main points is the fact that when we're using specifically autonomous database, ORDS already comes pre-installed and pre-configured. This means that we're saving a lot of the hassle of the configuration process for ORDS. And once our instance spins up, this means that we can go ahead and start REST enabling our database objects, and we can start publishing our REST APIs. With other forms of Oracle databases, not the ADB, we can still be able to install ORDS and configure it and run it anywhere, whether that's on cloud or on-premise. So I just want to show you a quick example here of this, where what an ORDS response would look like. So let's say we want to access our database and perform a select. We have a table called employees. We want to select all of the employees for a specific department. We can just write the query as seen here on the top. So we're accessing our host / going to ORDS / going to our database schema. In this case, it's called HR, to the table employees. And then we're writing our parameter, which is that we want department ID of 50. We insert it here as a query parameter. And then what ORDS does in the background is that it automatically generates the underlying SQL statement for that request. So it returns the results for us. And then here we see the results below. So you can see they're returned in the form of JSON. They're automatically returned in a paginated format. We can have links as well for each of these entries, as well as have them displayed in more detail. And this would be very useful when we're running our web applications. So we can, of course, be able to better visualize the data, and we can take full advantage of that. And by default, this requests and all the ORDS requests as well, they're secure by design. This means they're secure through the privileges that we've added to them, so that any source that attempts to use them that needs to be authenticated and authorized. This means that if you do not have the right identity or the right role, you will not be able to get access to the database. We can also use ORDS for publishing SQL Developer Web. This is basically a single page application that we can use in order to access and manage our databases. So you can run your queries in SQL worksheets here. You can have access, as you can see, to the performance hub. So you'd be able to monitor your database, monitor the workloads that it's currently having. And in addition, you also have your REST interface, like we mentioned earlier, that will allow you to be able to REST enable your objects and manage the REST APIs for them. And you will also have an interface in order to manage your JSON documents as well. With all of that, you would also be able to perform some data modeling. You can generate from that some useful relational diagrams for your data based on the tables and database objects that you have. And last but not least, you can manage your users as well. So this is as seen here on the left side of the screen. You would be able to manage the users, manage the privileges that you have assigned to them in order to better control the level of authorization. And as you can see, you would have full control and overview of the security of your apps and database objects. Then, as we noted, that ORDS is not just useful for relational data, but can also be used with non-relational forms of data. So if you want to use it for JSON documents, if we're going to use our database as a document store, for example, we can also use ORDS here for SODA in order to manage the documents and collections through REST APIs. This way, you'll be able to perform all of your get, post, delete, and put requests as you want that you normally would be if you were using a non-relational database like MongoDB, for example. Now, moving on to the highlight and the specific use case for today's session, which is database management REST through REST APIs. There are currently over 500 endpoints that are managing and monitoring all of your Oracle databases. This gives you access to different data APIs, different dictionary views via HTTPS. In the example on the screen here, we're using a POST request in order to initiate data pump requests on the database. So we easily pass the data pump parameters, as you can see in the request body here. And then you can see at the top of the screen, we have the URL. So again, we access our host, we go to the ORDS to the specific schema that we want, which is HR. And then we go with the specific API for doing a data pump / export function. Once the request executes, we get the response result here. So you can see this executes with a 200 status OK. We can see now from the screen itself that the data pump request is currently executed. We have currently 2 running data pumps. So this is just an example of one way of you managing your database itself through the REST APIs. So now, of course, the next question after talking about the use cases is, how do we actually get started with this? The process for getting started with ORDS is fairly straightforward. In fact, we can actually abstract it to just 3 main simple steps. We start, of course, by configuring ORDS in our environment, whether this is in an existing server like Tomcat, or we want to use it in a standalone format. Then we use one of our preferred tools, whether we plan on using the GRI that we have, the CLI, or APIs for this. We can then start REST enabling the schemas that we have in our database. And then the third step is that we start publishing our RESTful service, or specifically REST enabling some of the database objects like certain tables, certain views, for example. So what's more with all of this is you need to know that this is already included in your database license. This is even if you're running the free version currently, you will still have all the access to all of this. And ORDS is also able to support different types of architecture. So whether you're using the classic architecture where you have your single database, single tenant, or you want to have multi-tenant architecture, you will still be able to take advantage. This option is definitely, of course, handy when we're talking about lifecycle management, because if we have, for example, a container with hundreds of PDBs, we can still be able to install ORDS only once and be able to manage the lifecycle for all of the pluggable databases. And a huge advantage here also is the fact that the ORDS team is also the database team. This means that all of the new database features that are released or updated are also taken care of directly in ORDS, and the proper APIs for them are built as well. ORDS runs basically on a quarterly based release. Currently, I believe ORDS 22.41.1 has just been released. It's currently available. It has a couple of new features. It offers the feature of self-service schemas. This is very useful if you want to be able to create a database schema on a user request. This generates for you a secure URL that the users can then access from a public page in order to request for this schema. This may sound interesting, it may sound useful, but you're probably wondering, how does this actually help with CI/CD and lifecycle management? So let's talk about this now in detail and how we can manage a full production environment with CI/CD and microservices on top of the Oracle database using ORDS. So Oracle database is a perfect, of course, environment for supporting multi-tenant and multi-workloads model in the same instance. And this makes it ideal when we're talking about consolidation. And since version 19c, we're able to run multiple pluggable databases at no extra cost. So while this is, of course, a great setup to have, it raises the question of how will we be able to manage the lifecycle for all of the environments and the pluggable databases. And this is where ORDS comes in. It's possible for us to execute each supported HTTP perp. So we're talking about the get, post, and put delete requests on the database through the REST calls with ORDS. This means it's possible for us to manage the entire lifecycle of a pluggable database. We can invoke DTL in order to create database objects. We can create records and insert them in the applications as well, as per our needs. So if we think about this in terms of DevOps, this gives us the chance to change the entire pipeline with the applications that we have, with the changes in the code that we're making, and make the process way more efficient. So let's see easily how we can manage the PDB lifecycle with ORDS in just a few easy steps. We'll walk you through the steps in an overview manner. As we mentioned, this is not meant to go through all the technical details. We definitely have all of the documentation and available support material for this available that we can share later. So we'll go through this. We'll give you a solid run through of the process that we have here, just to see how simple and efficient it can actually be. We start at the beginning, of course, with the Oracle database. We need to have a container database with the PDB seed and ORDS installed at the CDB level. On CDB, we also need to create a common user with some privileges as seen in the statements on the screen here. And then we also need to create a test user in the PDB seed. And the purpose of the test user is that we will use it when we are creating our new PDB with the REST APIs as well. And then in the next steps, we need to configure some parameters for ORDS in order to enable the needed privileges. To ensure security, of course, we configure ORDS. We configure in ORDS who is going to be the user that's going to be admin at the container level and who will be admin at the PDB level. And then in the next step, we need to make sure that all of the PDBs that we have are addressable by ORDS, so we're actually able to connect to them. Then in the final step, the setup, we need to create a user with SQL administrator and system administrator privileges. And then that's it. In terms of the setup, we have configured ORDS in about 7 simple steps in order to be able to access and create our PDBs and execute data definition SQL on them. So now I just want to show you a quick demo of how this actually looks like. So we see this start first on the left side of the screen where we're checking to see if we have any existing PDBs. And we can see here that these are the PDBs that we currently have. And then we use ORDS in order to initiate a request as seen on the right side. So we use a post request in order to create a new PDB called prod. And then we can see here on the right side, once the request executes, we check and we're able to see our prod database here. We can see that it's already mounted and created. So here in the second example, if we want to test this further as well, so we can start to see if we're able to create database objects in the new PDB. Again, we're using the test user that we created earlier. We want to check first, of course, if we have any objects in the PDB itself. So as you can see on the left side, nothing is returned. We don't have any existing objects yet. So let's go ahead and start creating the new table. We create here a table called rest table, and we also enable the auto rest feature on it. That way, when we keep here the request is executing and we can see that the rest table is being created. Once this finishes executing, we can see here on the right side that we actually now have our rest table returned as a database object. So we can see below we have rest table and the type of this is actually a table. So we can create all of our database objects if we want directly like this example, or we can make it even easier and faster and run a script instead, or even by using the DBMS cloud package in object storage as well. And then here in the next video, we have, after we created the table, so we can go ahead now and start actually inserting records into the rest table that we created. So again, we start by checking the table itself. We can see that the count of the rows is currently 0. We don't have any data inserted. And we can go ahead and try to insert a new record in JSON format. So again, we're using another post request here in order to add the data. We have the data itself added in the request body. Once it executes, we can see that the count first is 1. We have 1 data row inserted. We execute the statement again. We now have 2 data rows inserted, and so on and so forth. So in addition to this post request, we can also automate this further. We can create a SQL script for this. So we can have bulk insertions on our table in order to simplify the process. And of course, in addition to these post queries we can also have get requests in order to retrieve the information on our PDBs and database objects. So we can get the records in this rest table, for example, that we created. We can also go ahead and drop our PDB through a delete request. We can choose to plug and unplug the PDBs as we need. So as we saw here, how easy it actually is to manage the lifecycle of our PDBs through ORDS. Thinking about this from the DevOps perspective can really provide us with an efficient way of managing our database and apps lifecycle. So now diving deeper into the DevOps part, I will stop my share here and hand over to Piotr to walk you through it.
Super, thanks a lot, Rana. So good morning, everyone. Thanks a lot, Rana, for going through the ORDS and all the useful functionality that it offers. It is truly the key to the autonomous database, as you had mentioned, as it does enable us to leverage the SQL Developer Web as an example, and all of the functionalities for the most part that we do have available within the interface. As you would always notice in the bottom left or bottom right corner, you would have the spinning cogwheel, right? That always says that the REST call has been successfully executed, and so on. So that indeed does make it a very crucial part. So where we take it from there, we take it to some DevOps, and how do we connect those two pieces together? As Rana has just shown, we're able to manipulate the database, we're able to manage the databases, we're able to insert data, create PDBs, as we know from an API point of view. all of the actions that we actually do within the Cloud Console, right? Most of those calls are REST APIs that are just simply executed, right? When we're, for example, starting the autonomous database, we're just executing commands in the background. But this is exactly what makes our DevOps processes more natural and gives it a better process of continuous integration, right? And continuous delivery, as we have mentioned. And the key to all of this is utilizing all of those features that we have, utilizing our ORDS, utilizing our Terraform and other applications to build a complete stack that allows us to give the speed and reliability that we expect from a modern database, from a modern data platform, that gives us the possibility to push and change between different environments and different landscapes as we are continuously working on newer and newer projects, right? So going off this, let's have a look at the next slide, which gives us the whole overview in terms of the features and the components that are actually included with the whole, let's say, DevOps process within the database itself, right? As we see, we have our ORDS in red here on the picture, being the key component to all of these operations, as we are looking at a whole and complete development life cycle, right? From the development environment to going to the production environment, and this happens in the flow that we see on the screen. So first of all, we would, as developers, or whoever wants to create or improve an application, whatever it is not. In this case, we have an Apex application as an example. So we are looking to maybe add a new column to the database on which the application sits, or perhaps we want to make some other changes, right? So we would open a new issue within our repository of choice. That could, of course, be GitHub. That could be our native DevOps platform, right? Whatever is the choice of the person. And then, of course, we have our autonomous database stack with all the APIs underneath it as well, including, of course, the Oracle Cloud API itself, which the Terraform works with. Then we also have Liquibase, which helps us with the extraction. And it's so important to keep in mind that all of these steps, all of the scripts that are executed for all of those actions to happen, right? Those scripts are executed through ORDS when they're interacting with the database. So that is a very important piece to keep in mind, and remember that most of the interactions that we would do with the database do happen through ORDS, and that could also a lot of the times make it basically a choke point, right? So it's a good idea to always have a look at that as well. Perhaps that might be the key to the issues, if there are any. Moving on, once we export our schema changes with the Liquibase, right? Since that's its job to see what has changed within the schema, within the database, what columns were modified, exactly, what columns were modified, and those changes of the schema are then pushed to the repository. So Julian, this is exactly the answer to your question right here. That's the role of Liquibase, where we extract the changes of the schemas from the database and then push them to the repository so that we can do our integration testing, so that we can do our unit testing, and so on before we progress further, right? And actually start pushing those new developments into our production environment. Moving forward, once we have all of those tests completed, approved, we then, as mentioned, proceed and push all of that to the production environment. And all of those things can pretty much happen simultaneously and in parallel. So we could actually have multiple development teams, right, working on multiple applications, and as long as those schemas are separate, right, and are not touching each other, we can have huge development teams working on multiple applications, pushing into a single production environment. That's how we would see the bigger teams work and operate. So to give an even more insightful look at what we are talking about, let's have a look at the workflow that you can see on the right hand side here. So this is what you would actually see in the deployment stack. This is what can actually be visible once you automate the whole process of your DevOps, right? And we can see that we start off with basically setting up Terraform, as this is our bread and butter for the core infrastructure, right? To actually deploy that autonomous database before we use ORDS to connect to it and do all of our extractions and all of our imports and exports as necessary. So once all of those Terraform actions are processed, then we look at Liquibase, right, to process those. And once that process is wrapped up, we are then ready to go and completely hands-off. We're able to create new databases. We're able to create new development environments with a fresh clone of production data, and the list is endless. The possibilities are endless here. So that is the power that our ORDS offers us in everyday lives, and the kind of advantages it gives us over other platforms as well, especially when it comes to creating your own REST APIs and then exposing them. And as we have seen in some of the Q&A questions, executing PL/SQL packages and performing really countless of operations, all of those do happen through ORDS indeed. And Bobby Bagashev asked one question, whether ORDS supports multi-cloud requests. So if you can import artifacts from Azure DevOps into ORDS, and that question is requires slight clarification on the second part, but I believe I do get the idea. And yes, that is something that is actually possible, and we'll touch upon that in a little while when we discuss the DBMS cloud packages. That is something that would most likely be used in that scenario. So now I'm just gonna show you a quick demo of how all of that works in action. Starting with a simple change within a schema, we'll see how those changes are extracted, how that looks from the kind of repository GitHub in this case perspective as well, and then we'll move on. So it's a very subtle change in this particular scenario, but if you have a look at the email address, you can see that it's a big text box. That's kind of the main key takeaway here at the moment. It's a big text box. But if I play this now, you'll be able to see that there is a change being made to that field. And then we go and extract the data. So you can see that the schema from the selected schemas from the database and the Apex application has been exported. And now I'm adding those and pushing those to the GitHub repository. Of course, all of these actions can be automated, but for the purpose of the demo, it's better to see how all of that works and how all of these changes are processed, right? So you can see that those changes are then immediately pushed to GitHub, and what we do then is create a pull request. So someone has delivered their job, someone has finished their ticket, right? Their request, and now we're simply merging that request with the current branch, with our, let's say, production environment, our production repository, as you would like to call it, and then that fires off a bunch of workflows automatically. So once the commit happens, all of the workflows are executed automatically. And then you can see, let me just scroll back a bit, and then you can see the actions that we have actually went through in the last slide. You can see all the different Terraform actions. You can see the liquid-based actions also taking place, and all of those are actually run from a workflow that's created within the GitHub repository in this case. So you can see the power of executing the remote APIs, and you can see how it can be remotely controlled in a very easy way. So once this completes, we can see that the subtle change is there at the end. You can see that the email address field is a single, it's a single text field. It's very small, but the key message here is to understand and see how the whole process and how the whole flow looks like. So now, as promised, I will quickly touch upon a functionality that hasn't been spoken around much, and it's the DBMS Cloud package, especially the parts that have the functions to act almost as a replacement to Liquibase, perhaps somewhere down the line in the future that could function exactly in that way, but there are still some little details that need to be worked on. But we do have a complete possibility to initialize and create repositories within the 4 platforms, our own platform, GitHub, and the others, of course. We can manage those repositories using the CRUD style, so create, read, update, delete style, which basically means that we can create new repositories, we can create new branches, delete those, we can insert files with the file management operations as well. So we have a complete control of our repositories using this PL SQL package, which of course can be executed through the REST APIs. So then we also have SQL install operations, which basically allow us to install and export all of those objects from our database. And what is key here is if you look at some of the other functionalities within the database, for example, some of the data pump functions that allow you to actually export the metadata of some of those objects, we can very quickly see how we can actually build our own CI/CD scenario using those functions, and that can work quite well as well. Lastly, but not least, we also have pipelines. So pipelines can be simply leveraged for continuous import and export of data, where we basically have alternating changes, right? And we just want to push those to our repository or perhaps a different environment altogether. And as you can see, it's just a simple screenshot that's showing, how one piece of DDL code for one of my schemas has been pushed to the repository. And I can say it works quite well, so I'm definitely recommending for those who haven't to check it out and give it a try. So from DBMS cloud perspective, that would be all. I just wanted to quickly mention that something like this exists, and it's very good to be aware that this could very much be the future when it comes to Apex, autonomous DevOps, and that stack, that technology stack. So that would be all from my side. If there is any questions on that part, please do ask away. Myself and Rana are more than happy to answer those. And in the meanwhile, I can see that Julian has asked a question. How a widely used CI/CD tool such as Jenkins fits here? So it doesn't at the moment, to be honest with you, but that is the plan for the future. I'm talking at least in terms of, let's say, Apex, a database. Probably if we look towards the end of this year, that's something that could fit in here. But currently, looking at the native DevOps that we offer on our cloud, that's where we can fit Jenkins in. But that does not fit in with the database process currently. Any other questions?
There's still something in the Q&A chat. I don't know if you already covered those.
Yeah, covered all of those in the Q&A chat along the way, and yep, that should be it. But happy to take more.
Right, we have some time left, so everybody, please feel free to use the Q&A, ask your questions.
Or you can raise your hand and I can unmute you and ask your question live.
If Bobby maybe could expand more on his question, because I tried to touch upon that in the DBMS cloud part, but maybe we can expand on this one. So let me take this one. Having an API gateway in front of ORDS, if yes, when? That's an interesting question. Honestly, that really largely depends on the use case and the end devices that will be communicating with the cloud in this case, right? Let's say you have, I don't know, some IoT devices that are out in the field, and perhaps you're looking for bidirectional communication with those, then an API gateway would be a good idea, right? Especially if those units perhaps do not have a fixed IP, then that definitely makes it a good use case. Otherwise, there is nothing that stops you from just executing that REST API from those devices, right? And if you have a managed ORDS environment that scales, as mentioned previously, horizontally, then you can have, hundreds, millions of those, maybe not millions, but hundreds of thousands of sensors and those devices, and push that data, right? And those ORDS servers would balance that and take care of it. Can we version APIs with ORDS? Yes, we can. If you create your own REST APIs, yes, you can export those, and you can also import those into other, let's say, environments. So if you imagine if you had created a lot of REST services in one database or in one environment, right? You can easily export those and import those into a different one as well. So it's very flexible that way.
Any further questions? We still have a bit of time left. Don't be shy.
We see a hand up somewhere.
Yeah, sorry, Piotr.
Yes.
About my question with Azure Artifacts. So I'm wondering basically if you have a Terraform configuration when it's in Azure. can you import the configuration back in ODS in the Oracle DevOps, or you need to perform special steps? And is it the whole configurations being imported, or is it just the database state?
Well, that really depends. I mean, you can actually look at a hybrid setup when it comes to that. Yeah, so you can honestly even split the process, right? So we are talking about Azure here, right? So you could even have, let's say, the CI part on Azure side, right? And then the CD part on the Oracle part. That's absolutely doable. Just depends on how you actually configure the workflows, but that's something that is possible.
Well, that's great. All right, thank you.
No problem. Anything else? It feels like ORDS is such a topic that, you know, it's always there, it's always looming, but nobody is ever talking about it, it seems.
Right.
Thank you for the feedback, guys.
I guess that's it then. Do you have anything else to mention before I close the session, Piotr or Rana?
Just a huge thank you to everyone watching it.
Exactly. Thank you so much for your time.
Right, okay, perfect. Thank you too. Thanks a lot for this presentation. Thanks everybody for tagging along and for joining this presentation. So thanks again for everybody and have a great day. Bye-bye.